Welcome to my channel BioQuest Biochemistry classes. I am back with a video on order of draw or order of blood draw. Order of draw or order of blood draw, it is a fundamental, rather vital step in the phlebotomy disc. Now let us know what is that. To avoid cross contamination, it is the way or sequence in which blood should be collected in vials. Now for remembering the order of blood draw, let us go for a mnemonic 3CHEFA. C, 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 H, E, F and A. First C stands for culture. Second one for citrate. Third C for clot. H for heparin or heparinized vial. E for EDTA, ethylene diamine tetracetic acid. F for fluoride and A for acid citrate dextrose. Now let us look at each of the vial. First one is culture. This is the first bottle. For this we have the bottle in which blood should be collected. Now this blood culture bottle, it should first go for aerobic culture and then for anaerobic culture. If the sample is inadequate, we will only proceed for aerobic culture. This can be a normal flat bottle that has a capacity of 120 ml or BHI infusion bottle which has a capacity of 50 ml, and nowadays we use backed alert bottles where they have a semi-permeable membrane that shows the color change due to change of pH due to diffusion of carbon dioxide through the semi-permeable membrane. Now the amount of blood that should be collected in the blood culture bottle, it should be 5 to 10 ml in cases of adult patient and 1 to 5 ml in cases of pediatric population. Now what is the anticoagulant for blood culture bottle? It is sodium polyanethol sulfonate. It is SPS. SPS stands for sodium polyanethol sulfonate. Why not EDTA, citrate or heparin? Because they itself inhibit the growth of the microbes or microbial organisms. Next one is citrate. Citrate, what we do for citrate? Citrate is mainly used for coagulation profile. So this is the citrate vial. It is blue color capped vial, and the citrate used for this is strength of 3.2%. Citrate is used. Many of you may be having the knowledge that we use 3.8% sodium citrate for ESR estimation, but here we use 3.2% strength, and it should be used in a particular ratio, that is in the ratio of 1:9. Up to the mark in the bottle we should collect the blood, because this dilution is very important for the studies. Where it is used, I have said, for the coagulation studies like prothrombin time, APTT, then we use for INR estimation, and in biochemical lab we use for estimation of D-dimer, fibrinogen, we use the citrate vial, and after collection we should go for gentle inversion like this for 3 to 5 times, not more than that. After that, the third C is for clot vials or the serum separation tubes. These are the clot vials or the serum separation tubes. Here I have two types of vial. First one is red capped and second one is yellow capped. Yellow capped, if you look, there is a gel at the bottom of the vial. There is a gel that is placed at the bottom of the vial, and here no anticoagulant is added. Whenever we collect the blood, we should go for gentle inversion for 8 to 10 times. Where it is used in most of the routine chemistry tests that we are going to perform in the biochemical lab, for the thyroid hormone analysis, for the lipid profile quantification, for liver enzymes assay. We use this clot vials or the serum separation tubes. Now third one, that is the E, that is the heparinized vial. Heparinized vial. This heparinized vial, they are having two types of heparin salt. Like this one, this is a bit dark green in color and it is having sodium heparin. It is having sodium heparin. Another one is there that is having light cap color, light green cap color, and that is having lithium heparin. So this one, this heparinized vial, that are used for the rapid tests, because they are also known as plasma separation tube. When we want the test to be done rapidly, then this type of vials are used. Heparin is also used as the anticoagulant of choice in arterial blood gas analysis, but don't get confused. In arterial blood gas analysis, we draw the arterial blood in the syringes, not in the vials. And these vials, they are mainly used for the rapid test, and they belong to the category of plasma separation tubes, and they are also used in studies like cytogenetics. We use this heparinized vial. Heparinized vial. So two types of salts I have already mentioned for heparin vial. One is the sodium heparin, another one is the lithium heparin. Next one is the EDTA vial, that is having the purple or the lavender capped vials. This one, purple or the lavender capped vial. This one, that is having the light pink color capped vial. It is having the potassium salt of EDTA, K2 EDTA. And this one, that is having the purple or the lavender cap, that is having the K3 EDTA. So two types of salts are there, potassium or tripotassium. As per International Council of Standardization, they say that K2 EDTA is the preferred anticoagulant among these two. K2 is the preferred one. Now this EDTA, that is used most commonly in the hematological lab for the complete blood count. Then they use it for routine hematological tests, but it is important in biochemical lab also. This one, this EDTA vial, it is used for estimation of HbA1c, that is glycated hemoglobin. It is used for the quantification of glucose 6-phosphate dehydrogenase enzyme. This EDTA vial, it is used for the estimation of parathyroid hormone. It is used for the quantification of ACTH hormone. It is also used for the estimation of plasma renin activity. So all the blood samples for this type of biochemical test should be collected in the EDTA vial. Last one is the fluoride vial. Fluoride, there is a common question, catch question in the vial, that what is the anticoagulant in the fluoride vial. Now, initially it was oxalate and fluoride, where oxalate was the anticoagulant and fluoride, it has mild anticoagulant property, but it is basically anti-glycolytic. It inhibits the enolase enzyme of the glycolytic pathway. Why it is essential? So that the plasma glucose can be quantified accurately. If glycolysis could have gone, then the time when we would have measured, entire glucose would be consumed in the plasma by the cells. That's why anti-glycolytic inhibitor, that is fluoride, is added. In recent times, you may find in your lab that it is also marked as EDTA fluoride vial. So oxalate fluoride vial is also there, EDTA, where they are acting as the anticoagulant. And last one, acid citrate dextrose. This is the anticoagulant of choice in cases of blood collection camps, where we are taking the blood in the blood bags for blood donations. There we use the acid citrate dextrose. So for simple purpose, whenever you are going for an estimation of, or what is the order of blood draw, you should remember this 3C HEFA. First C, culture, then citrate, then clot, then we have heparin, EDTA, fluoride and acid citrate dextrose. So This was a simple video, the basics of phlebotomy or the basics in internship or in first year PG days where you have to collect the blood. Remember this, because if you don't follow this order, you may cross contaminate and you may get bizarre looking results. If you like the channel or if you like my videos, do like, share and subscribe. Keep watching. Thanks for watching.